In this video, we're going to discuss the difference between a linear and exponential function. A linear function is a function that changes at some constant rate, meaning as our input changes by a specific value, the output value will change at one specific rate. An exponential function is a function that will change proportionately. The way that we set up each one of these functions is a little bit different. A linear function will be in the form b plus mx, where b is the vertical intercept and m is the slope. An exponential function will be in the form a times b of the x, where a is the initial value, which is also a vertical intercept, and b will be the common ratio. Let's look at a table and see if we can determine which type of function we're considering. In this first table, we notice that as our input values increase by 1, we get a constant change in our outputs. They are increasing by 4 every time our input value increases by 1. This shows that we have a linear relationship, and it will be in the form f of x equals b plus mx. M is our slope, which is the change in outputs over change in inputs. So m will be 4 over 1, which the vertical intercept, that's equivalent to our output when we input 0. So in this case, it'll be 12. So we can write that our function is 12 plus 4x. Let's look at the next table. Here, as we increase our input by 1, we notice that, in fact, the values are decreasing at different rates. We're decreasing by 12 initially, then by 6, and by 3. We're actually experiencing a proportional change. If we consider the proportion 12 to 24, we'll notice that that is equal to 6 over 12 and 3 over 6. We have a proportional change of 1/2 as we increase the input by 1. That shows us that this is in fact going to be an exponential function and take on this form. That proportional change, that is our common ratio. The a value is our initial value, which is equivalent to our vertical intercept. So we can write that this table could be modeled by the function 24 times 1/2 to the x. In both of those table examples, it was fairly obvious to pull out the vertical intercept, or the initial value, as well as the slope or the common ratio. But let's talk about what we can do if it's a little bit less obvious. How can we write these from just 2 points? So if I know I want to write a linear function, I'm considering that I'm going to write a function in this form. We can begin by finding the slope and working backwards to find the vertical intercept. So let's start off by finding the slope. We know the slope is the change in outputs divided by the change in inputs. So 7 minus 3 over 4 minus negative 2 gives us 4 over 6, which is 2/3. So far I know my slope is 2/3. We can then use either one of those points to work backwards to find the vertical intercept. So let's say I consider taking the point negative 2, 3. That tells me the output is 3 when the input is negative 2. We can then solve this equation for b. So 3 equals b minus 4 over 3. And if we add 4 over 3 to each side, b is going to equal 13 over 3. So we get the function f of x equals 13 over 3 plus 2 over 3x. Let's try and do something similar now, but for an exponential function. So in this exponential function, we want to try and write a g of x function. We're going to use the fact that we know exponential functions grow proportionately to begin by solving for b. So what that tells me is that a times b to the fourth over a times b to the first needs to result in 7.8732 over 10.8. This shows the proportional relationship that we would expect. We can simplify the left side. A over a would cancel, and then b to the fourth over b to the first power, using exponent rules, is b to the third power. I can then solve this equation for b by taking the cube root, and we arrive at b equals, and the result is that b equals 0.9. So far, g of x equals a times 0.9 to the x. And again, that's just using that proportional relationship. Now we can work backwards similarly to how we did with the linear function. So let's plug in the output of 10.8 with an input value of 1. So I'm just dividing both sides by 0.9 to the first power. And the result will be that a equals 12. So now we have all the parts that we need to put together our exponential function. It'll be f of x equals 12 times 0.9 to a power of x.